Alright, time for the math. Easy. So we're trying to discuss the derivative of hyperbolic functions. Look at hyperbolic sine, cosine, and tan. Oh, I'll just cross this out. It's spelled wrong. But anyways, yeah, I showed in my earlier video what hyperbolic functions are. Now I'll just look at the derivative. Derivative is just straightforward. So if you have say y is equal to sine h, I showed my definition of them. They are just equal. This one just equal to e to the x minus e to the negative x. Yeah, so these functions arise a lot in engineering and whatnot. So basically, derivative, you just go dy, which equals 2 d sine h x over dx. So you just do derivative directly from here. This one's just going to equal 2. Well, this is a constant. Just take it out. Well, using derivatives we showed before, power of derivative e to the x is just e to the x. And then minus, well, derivative of this, you're going to use chain rule, so it's e to the negative x times it by the derivative of negative x, which is just negative 1, or just put a plus. So the two negatives come to positive. And this one is actually just equal to, well, this is cos hx. Yeah, so this is actually definition of cosh, or hyperbolic cos x. And then the basic derivative of, if you have y is equal to cos h of x, which equals 2, well, this is just this, e to the x plus e negative x over 2. So if you want to do derivative, y prime is just going to be equal to, well, same thing as before, 1 over 2, this one's going to be e to the x, this is going to be, well, this is going to be, let's say, plus e to the negative x. Using chain rule, this becomes a negative. Yeah, and this one is basically just equal to sine h of x. So now the last one to look at is just tan. So if you have y is equal to tan h of x, which equals 2, which equals 2 is sine h of x over cos h of x. So then this one we just use again y prime is equal to. So now with this one you could use either a product rule or a chain rule, or you could use either product rule and chain rule or just quotient rule. And this one you could either memorize the quotient rule, or just do this little trick to just use product rule, which is just rewrite it as let's just write y is equal to, well, sine h of x times cos h of x power of negative 1. So now we could just use direct chain rule. Chain rule and this product rule right here, so we can just drag it down here. We're gonna have y prime is equal to, well, sine h, the derivative of that is just cos hx, and then, well, the cos hx times by, well, this one is cos h using the chain rule, and then I'm using product rule, the plus. Now we do derivative of this one. Derivative of this one is going to be equal to, well, we'll just write sine h first. Just write sine h, and then we just write the derivative of it here. Times by, this is going to be negative 1, bring it down, cos h of x. Yeah, I'll just drag it down here so I have some space. So this is plus this one right here, I'll just put plus as well. Plus here, cos h, so negative cos hx, using the product rule. This is cos h of x. Put a negative 1 down there, and then this is times it by, negative cos hx times by, this one is going to be negative 2. Bring it down, then using the chain rule, which is then we just times by the derivative of the inside here. Cos h is a sine h of x. And this one is just equal to that. And then now we can just add these all together. So we're going to have this one's actually cancelled, this equals to 1. 1 plus this one here plus sine, this is squared and then divided by that, so this is actually negative here. We'll just write negative sine h squared of x divided by cos h squared of x, and this one is equal to, well, this is, so I'll just write it down here, equal to 1 minus, this is just tan squared of x, tan h squared. And now we could further simplify this, because I showed in my other video the identity that you have cos h squared of x minus sine squared of h of x is equal to 1. So then if you were just to divide this all out by cosh, divide this by cosh h squared of x, divided by cosh squared h of x, this is hx, this h of x, this one, then this is going to be equal to 1 minus, this is tan h of x, then this one is just secant h, just the inverse of that, secant squared x. So there's our identity right here. So this one, you can just simplify it to equal to right here. So secant, hyperbolic secant of x squared. So yeah, this is similar to the trig. So basically, to summarize it, yeah, you got, basically, I'll just write it up here. So for tan, the derivative is just right here. Yeah, I'll just summarize right here. So if you have, let's say y is equal to tan h of x, the derivative is equal to secant squared h of x, and if you have y prime, no, y is equal to sine h of x, the derivative, I'll just write it's y prime is equal to cos h of x. And similarly, if you have y is equal to cos h of x, and then this one is going to be equal to y prime is equal to sine h squared. I mean x, no squared. Yeah, well, that's all for today. This is just summary of here. It's just very similar to trig identities. I mean trig derivatives, except there's no negative here for derivative of cosine squared. I mean of cosine x. Well, that's all for today. Hopefully you learned, and yeah, stay tuned for another math easy solution.